Welcome to today's webinar, Database Consistency with High Performance. How does it change my digital transformation? My name is Matt Bichelle, Director of Product Marketing at Aerospike. Before we get started with today's webinar, I'd like to offer up some housekeeping. First, copies of slides and the recording itself will be made available after today's session. We'll be holding questions to the very end, but feel free to, and please do, use either or both the comment or the questions window. Today's presenter, Brian Bulkowski, is the founder and CTO of Aerospike. With almost 30 years of experience in Silicon Valley, Brian's motivation for starting the company was the confluence of what he saw as the rapidly advancing flash storage technology, along with its lower costs that weren't being fully leveraged by database systems, as well as the scaling limitations of sharded MySQL systems and the need for a new distributed database. He was able to see all of these needs as both a lead engineer at Novell and chief architect at Cable Solutions at Liberate, where he built a high-performance embedded networking stack and high-scale broadcast server infrastructure. So with that, Brian, please take away.
Thank you, Matt. Today we're going to talk about database consistency and high performance. At Aerospike, we have seen a need driven by the enterprise transformation for databases which are not only fast and easy to use, as NoSQL has become, but also correct. The driver of digital transformation is really the attack of internet companies upon the traditional enterprises. What we see on the left-hand side, the captains of industry and large-scale companies that took us through the latter part of last century, were assaulted by a variety of internet companies, from companies like PayPal and Apple going after the payment processing space, to retail being transformed by Amazon and others, as well as television and media being transformed by over-the-top experiences. We're all well aware of the change in transportation that occurred with Uber, Waze, Ola, and other cab companies taking on the traditional ones, and a variety of changes in media. What puts together all of these experiences is that the internet experience is real-time, it is rich, it is engaging, and often has small components of the user experience that must be carefully managed, but also are at very high loads. The traditional enterprises worked very hard to create systems that were highly accurate and befitting the kind of experience they wanted to create, where as a large enterprise, their word was correct and their transactions, the pricing, etc., was always accurate as a high quality experience from that regard. But often in the new world has fallen on the fact that the experiences are simply not as rich. The transformation that occurs is really coming across multiple industry segments. It has been driven to some extent by NoSQL systems that have been put in addition to the traditional enterprise databases such as Oracle, DB2, and others. So these systems then have to deal with more data and more real-time aspects. A selection are seen here. You can see that, for example, online reservations, the airline industry and travel industry continues to struggle with the fact that if I go to an aggregator site, I may see a plane flight, I may go through booking it, and then I may find that that particular reservation is no longer available. The travel industry is very complex with aggregators, the actual booking agents and agencies, and then fairly traditional, even AS400 style IBM systems doing back-end reservations. The complexity is very high, which makes enterprise systems a challenge, and yet people on the internet demand a much higher fidelity and much more richness in their response. The cases of threat detection and fraud are another example. With the internet, we no longer have cards that are present at a retailer who can look at you. And even though there was challenges in fraud with credit cards in retail environments, the risk is much higher once we've gone to the online world where cards are not present, where internet retailers are all online, where someone may buy in one country and buy simultaneously in another country simply because they had two browsers open. In these older systems, what we had was a system of record, which was often called the transaction system or transaction processor, as well as these new systems of engagement. And in the last 10 years, these traditional enterprises have started onboarding a separate system of engagement, and have needed to relax consistency guarantees and correctness guarantees in order to gain the scope of data and performance that they need to match the experiences of the internet giants. So when you are making your actual reservation, you would go to a system of record. And yet, if you want to know what reservations are available or what pricing is available, you would go to a system of engagement. The gap between these two systems is always difficult from a variety of reasons. One is the system of engagement is a different technology base. It's often NoSQL, it's often in memory, where a system of record is usually a SQL system with a storage subsystem, storage layers, etc. So even though these companies have been able to bring together a richer experience, they've done it at the cost of technical complexity, and they suffer from poor user experience when there is two systems, and thus the system of engagement is incorrect. What we believe at Aerospike is that with new database technology, you can have both of these worlds. This is a bold claim, and the ability to have strong consistency, true database strong consistency with transactions, all the way through to a storage layer, in our case, Aerospike's case, optimized for flash storage, and also maintain million transactions per second performance that Aerospike is known for. This is a bold claim, and I will do my best during this talk to validate that we have done this. However, I do, if this sparks interest, Aerospike has a variety of technical documentation on our website, or reach out to us directly for more technical information. However, we have achieved the ability to do strong consistency with high performance. It's important to note that eventual consistency is a different problem from not losing your data. An eventual consistency system simply denotes that it is asynchronous. A strong consistency system shows that each individual write will be written to storage if desired, and will present a linear flow per record of transactions, which is to say, your writes will not be lost. And an eventual consistency system, due to its asynchronous nature, but also due to the kind of buffering constraints that are common in NoSQL, can simply lose data, and eventual consistency does not make up for that. In the overall database landscape, what we saw was the structured data on the left-hand side being supplanted by the new NoSQL systems that were either based on unstructured data, but could be either an in-memory system for transactional basis, such as an in-memory system like Redis Labs or Cassandra, or it could be a true big data system with petabytes of storage used for analytics. What we are now seeing is database technology that is capable of bridging the gap both in petabytes of data, terabytes and petabytes of data that are on the front edge, thus making analysis possible. Analysis, compared to analytics, is the ability to do that kind of careful, sensitive, but also rich experience on the front edge of your system. It's not about the kind of long-term analysis that you would use over petabytes of storage in your back-end systems, but instead finding an audience, a cohort, finding recent behavior within that group and using that to make a richer experience moment by moment. These kinds of systems, when mated with and the same system as your transaction system, show the kind of power that people now expect as part of their online experience. This overall architecture, we find, is driven by using a database level that is high performance, instead of using a caching layer. We find that many enterprises still consider a caching technology to be appropriate in front of a more traditional system or even a first-generation NoSQL system. That architecture has a number of issues. The first of which, of course, is caches are expensive. Not only do you have to build out a database layer, you have to build out and maintain a caching layer. The primary use of those are RAM-based systems. There's a level of complexity. Do you have the right size cache? Is that cache overwhelmed at a particular moment? Is the cache right-sized for peak load, which you may only know in the heat of the moment? The final problem, again, is consistency. Once you have a cache, that cache can become out of date with the database layer itself. A database which has integrated caching, internal caching, but then also has the performance, provides the optimal solution of both correctness but also performance. Now with the ability to do transactional data in the same database, that provides a supplanting and an addition to the traditional transactional systems as well. What we've seen so far is that transformations within enterprises do require keeping your traditional system, primarily for reporting and older scripts. That should not be a great concern because with reliable message queues, it is possible to keep both of these systems online, where your high performance NoSQL system, it becomes your primary source of truth, and yet you still have a reporting system for some of your low load cases. With this kind of architecture, that the traditional enterprise relational databases still play a role, but that role becomes one of correctness, reporting, and dealing with regulators, as opposed to the moment-by-moment user experience. In order to provide the correct feature set for that enterprises need to integrate with their environment, we see a broad number that are required, notably security. At Aerospike, we've been able to add the traditional enterprise security features, such as in-database encryption, the ability to have high-quality transport encryption, TLS 1.2 with AES, which it can be done these days with modern Intel processors with a very minor difference in performance. Integration with back-end LDAP and access control systems, as well as enterprise logging, becomes critical as well. Geographic replication is also key to any enterprise application. The ability to handle writes to multiple data centers and to be able to eventually have them be correct and correct within an individual data center is absolutely key. Aerospike's replication technology, based on its performance within high availability ad tech scenarios, is robust. We've also found now that being able to have SQL analysis through Spark is a highly requested feature. While most NoSQL systems and most Aerospike and analysis systems use direct access through APIs and microservices, we also find that being able to enable SQL analysis through the Spark framework is a key necessary feature. The benefit of using a system like Aerospike is the latency that ends up happening. For high latency applications, applications that may be satisfied by 10 to 20 millisecond requests per query, we find that traditional relational systems are up to snuff, and first generation NoSQL systems such as Mongo can fill the bill quite easily. However, it's really the real-time applications and online applications where you see the kind of requirement. In this real-world customer environment, we see the kind of system where Cassandra is used on the left-hand side, and it is seeming to perform well, but you do see latency dips and you do see latency problems that flatten out almost consistently when Aerospike was put in place across a Cassandra to Aerospike transition. So we then see a 99.9% latency request. This becomes critical when doing the kind of analysis that occurs on the front edge of applications, because often hundreds, if not thousands, of individual data points are required to bring together a rich customer experience. When you are bringing together 1,000 requests, suddenly your 99.9% latency becomes your average latency. When latency is required, these systems are key. Besides latency, what we find is that providing this kind of high performance, strong consistency at a reasonable price is necessary. For all of these enterprises, they often have traditional databases which are in fact high performance. The older mainframe systems, System Z, other systems, do absolutely provide high performance and low latency, but simply at a cost that is growing every year. Between cloud providers, between the flexibility that is required, between being able to roll out geographically distributed systems, cost really becomes the issue. Rolling in a new $10 million mainframe to a smaller country, while it might be possible, is simply not in the cards, even for large enterprises. Thus, being able to provide at a reasonable price a flash-based solution, which undercuts a RAM-based solution or an earlier first-generation NoSQL, saves literally millions of dollars. At Aerospike, we typically take the customer's needs and requirements from a latency and size and are able to easily contrast it with a variety of databases and often save millions of dollars. Those millions of dollars become really the basis of being able to transform. Every transformation project has a budget, and while there is a desire to meet the internet giants, it always has to stay within a reasonable project budget. Aerospike, of course, is part of the transformational aspect that is the cloud. What we see as part of cloud deployments is a multi-pronged approach, some call it polycloud, where there is a role for traditional bare metal, but there is also a role for public cloud environments. Now, different data sets and different data sources may not be appropriate for the public cloud, and that often brings in a form of orchestration mechanism. We see a lot of Pivotal Cloud Foundry, which allows someone to, an enterprise, to have some portions of their data and application in different cloud environments, as well as to be able to use local bare metal for higher security as well as higher price performance. Within all of these, a database like Aerospike, which is clustered, which doesn't require any special hardware, becomes the obvious choice. Really, it's a transformation that has been led by advertising companies. When you think about the amount of personalization that we know is possible within advertising and the rich system of identity management, user understanding, time series, local time series, those ad tech capabilities have been adopted by a wide variety of up-and-coming internet companies as well that you see on the right-hand side. Companies like Airtel have been able to create much deeper customer understanding and world-leading apps in terms of what network capacity is available. We see technology companies that are able to bring together a higher understanding of their customers and lower, richer experience. We see gaming companies that absolutely require much higher fidelity of experience, as well as the more obvious cases in financial services. So let's talk a little bit about strong consistency and what it can bring. In these different cases, let's pick a few of them. In fraud detection, what we have found is that while there is behavioral information that can be done with traditional AP NoSQL databases, what we also find is that some of the data in our customers doing fraud detection, higher fidelity is required, and those traditional systems have been Oracle systems. A well-tuned Oracle system is capable of both a fairly high level of performance, but at a very high cost. So we see systems that are a combination of Oracle technologies, often terracotta caches, rack clusters, times 10 systems, being supplanted by the need for strong consistency. Within Customer 360 in retail, we've seen a lot of interesting cases as well. What we see is that the kind of customer experience, you don't want to receive an offer from a potential supplier to you, a cell phone provider, say, when you already have an account, or the chance to upgrade a phone when, in fact, yesterday you already updated your phone. The kind of fidelity of data that becomes the hallmark of the enterprise and a core piece of the experience. All of these are cases where either a choice was made to go to a Cassandra system or traditional relational plus cache systems are giving way to the larger data volumes, but also the larger capabilities of a NoSQL system. In the case of retail banking, you might imagine that the new applications that are coming online have created a much greater demand on the traditional database. An order management system within a retail bank, for example, would typically be based on a traditional relational system for consistency and correctness, as well as a cache. A few years ago at Aerospike, we were called in to take a look at a system where consistency was failing due to a caching layer that would come online, come offline, the typical problems of an in-memory system, but also would have the problem that a RAM-based older in-memory system simply didn't have the level of performance required. This kind of system with every new app was needing to add hundreds, literally hundreds of new RAM-based cache servers, and instead being able to move to a flash-based system created a microservice that was able to be used by all of the applications. Being able to then write an application which could be velocity limited based on its priority through a microservice layer, but still have access to the correct and accurate moment-by-moment trade characteristics became a huge business benefit. Real-time risk, part of the equation, because it allows in-flight transactions, which are the most risky of a component book, to be analyzed, as well as the most recent systems in order to recommend and provide up-to-date mobile applications. In case of a customer engagement, we find that retail really has a number of components that can be changed by digital transformation. The first, most obvious, has been the integration with advertising systems. Once you start integrating with your advertising supplier and starting to form programmatic associations and starting to do deeper retargeting, which can be done through a variety of systems, once you have an abandoned cart, for example, once you have a user engagement and you don't see a user, these forms of search retargeting and buy experience retargeting have been done for a while. But it turns out that if you, as a retailer, start using more of your internal data to go even further in terms of programmatic buying in particular, you don't end up exposing to outside sources some of this information for retargeting. Keeping your data in-house as a large retailer ends up being a very important business benefit. Amazon, of course, doesn't export the internals of what they do, neither does Google on any of their sites. Large retailers also need to build up their own sources of user experience when they are doing advertising integration. Once you start building up that kind of store, again, it's essential to have one fast store as opposed to multiple siloed stores within your organization, so that the fraud detection organizations can look at what's happening within the advertising component. All of that allows creation of a much, much richer and much more correct experience for the user across a variety of experiences. Within interactive payments, the ability to have strong consistency at these multi-million transaction levels really becomes a key to providing much, much more accurate fraud prevention. Some of that is during the transaction pipeline, being able to look at, in the 750 milliseconds, a broad variety of data, not just location data, but also to use a wide variety of ML techniques. So we find that the older rules engines-based systems for fraud prevention, while they're still in use and still have a lot of benefit, being able to use machine learning in these systems is key. Machine learning at scale requires not generating, say, SQL statements, some people do that, but instead being able to have a broad variety of features which could be used by your ML agents moment by moment. That often requires fetching thousands of individual data points as input to your model and being able to run them. With the kind of system that Aerospike has that is capable of hundreds of terabytes on the front edge in a cost-effective fashion, building these kinds of ML systems, I wouldn't say it's child's play at these kind of scale, but it becomes possible. Now, part of the benefit that Aerospike has found is based on our hybrid memory subsystem. And even though that's unchanged in Aerospike 4.0, I'd like to spend a moment to give you an overview on it. At Aerospike, what we found was that traditional relational databases and first-generation NoSQL systems were still burdened by a technology architecture that had relied on a few key normal bottlenecks. One of them is the disk bottleneck. Now, disk issues have been with databases for a long time, and there's 40 to 50 years worth of research in how to optimize for various different disk subsystems. We had the advent of in-memory systems, which did not have a disk bottleneck, but instead had to pay the price of high RAM costs. One technique was to use internal tiering, but that also has performance problems because you have a CPU that has to go look in a cache, copy data over into a cache, and keep a cache synchronized with storage. Multi-level tiers become slower and slower as you have more levels to look into and look up. Instead, by creating a hybrid memory architecture, which uses flash as the core component of storage and RAM as the elements of index, as opposed to, say, a log-structured merge tree that's common within NoSQL systems, or even traditional group commit database systems, you end up with a far higher performance system. The kind of network optimization that we did with Aerospike revolves around the ability to do transactions in a safe and effective system. With a smart client, which becomes the form of load balancer, you have a system that knows where data is, the ability to moment by moment update which clients are talking to which servers for which keys and records, as well as being able to code in a high performance multi-threaded environment. Now, some of the older relational systems, Oracle in particular, are wonderful at high-performance C optimizations. Some of that technology did not make it into some of the newer NoSQL systems. The essence of hybrid memory is the ability to be able to use both flash and RAM for what each component is good for, as opposed to trying to use a paging system which is unaware of the different requirements. The requirements on an index in a database are the ability to be able to access with a lot of parallelism. You need individual requests to be able to share an index and to be able to update an index rapidly. The traditional database trick in a benchmark has always been to warm up a cache to make sure it's in memory. Well, with Aerospike, we have optimized the index so it is incredibly small, far lower memory footprint than any of our competitors, and also the ability to be able to update it rapidly and in a parallel fashion. With that kind of high performance and small indexing technology that is purely in RAM, we can then go to a very large flash subsystem with an optimized data layout. Now, the problems of high performance and strong consistency are several, and they have been attempted to be addressed by some NoSQL systems. So I'd like to take you through what to look for when considering the consistency aspects of different databases. Now, you may find databases which are highly consistent, but simply don't have the performance characteristics to keep up with your load. In essence, this becomes a consistency risk. If your database simply can't take writes at the rate you need, if you can't capture every click, if you can't capture a load spike, and you're dropping some on the floor because you have low performance, well, in some sense, you have data loss because you can't take every write. When you look at an architecture of a distributed system, what we've learned at Aerospike is there's a wide variety of pitfalls. One of the most classics is the clock. Within a distributed system, it's a well-known research problem that you can't simply use a system clock on an individual machine and trust it. In Aerospike, we used one of the distributed systems techniques. You find some clocks, such as the widely used vector clock, which simply don't have the performance, even though they have correctness. Another classic problem in distributed systems is the fact that writes are often buffered. which will cause a crash to lose data that was acknowledged. This kind of system is often called a K-safety system, and if you have enough RAM and enough copies, can provide enough resiliency and enough durability. However, it's great to have the option to be able to use the actual storage layer as well as a truly committed store. Asynchronous replication is one of the ways to get to a high-performance system. However, that has the obvious failures that data can often be read in either stale or dirty locations. Finally, even with a correct architecture, we find that there are systems that simply are buggy. When you look at some of the consistency reports, you see systems that are hamstrung with multiple crashes, with software that simply doesn't work yet, even though they might have a correct design. At Aerospike, we provide the kind of performance we do because we have created one limitation, which is that our consistency guarantee is on the primary key. Now, primary key consistency, which is called, say, linearizable consistency, is different from serializability. With serializability, you need to make sure that the entire index or entire table is correct across multiple different requests and a wide variety of hazards. Traditional relational systems have a wide number of excellent tricks to be able to provide the performance they can in the face of that requirement. But what we find with transactional systems in particular is the primary key really is a highly effective manner to provide consistency. If you have an account, that one account, you need to be able to update it, provide status, transfer money in and out in a linear fashion. Primary key really is the most useful form of consistency and can be provided at the kind of performance that we do. And yet you still need more technology under the covers. Our hybrid memory architecture, as I mentioned, a transaction model that provides the essence of a two-phase commit by writing to a master and then writing safely to replicas. The ability to specify the nodes that are in and out of a cluster in not a laissez-faire gossip fashion, but with a strong distributed transaction behind it, as well as a high-performance distributed clock, which is correct as well. All of these technologies Aerospike brought into Aerospike 4.0. When talking about data loss in a distributed system, it is often difficult to determine if a distributed system will lose data along edge conditions. It's easy to provide a performance measurement, but hard to provide all of the different kind of edge conditions that may cause data loss. What we have found in the industry is that there is a researcher, a man by the name of Kyle Kingsbury, who has created a set of consistency and correctness tests that he calls the Jepsen tests. The Jepsen tests really go through a wide variety of transaction model updates and especially distributed system tortures to break clusters into pieces, to apply transactions into multiple parts. And Kyle has taken a variety of NoSQL systems to task for not providing consistency or not providing the consistency that they, in fact, guaranteed or stated they would. The Jepsen tests results are summarized, some of them, in this table, but I do suggest going and taking a look at Jepsen.io and looking at the research reports in depth. They can be challenging to read for a layperson, but they clearly show that systems like Redis and Cassandra and Aerospike in 2015 were rife with different trade-offs which would lead to data loss. MongoDB went through a period of improvement and a number of different Jepsen reports, resulting finally in 2017 in a system that showed strong consistency according to the tests that Jepsen had. CockroachDB, I would also recommend taking a look at. The research on that paper I find still reading. It's hard for me to tell whether it is passing or failing. Aerospike recently was published by Jepsen as well, and you can see a report there that shows that Aerospike, to the best testing capabilities and in split brains, multiple transactions, retransmissions, does not violate the linearizability concerns that that system tests for. So what this then provides is the ability to provide a NoSQL system with the highest level of transactional integrity within the constraint of a single key system that can provide the underpinnings of that kind of high quality enterprise experience that you need. If you need to be able to make sure that airline reservations are correct, that 5 pages along I don't cancel out, if I need to make sure that every single risky transaction is included in a risk calculation, if I need to be able to make sure that every person I send an offer letter out to for a new service is in fact not a customer, all of those enterprise experiences really demand strong consistency. And yet, in the new world, also demand ramping up performance and data capabilities, the essence of a transformation. With all of these, we really find that Aerospike has been at the core of new transformations and is an exciting addition to the database landscape. Hopefully this has given you an overview of some of the ideas behind being able to provide strong consistency and what it could bring to your transformation. I hope that you will take a look at some of the stuff that we have on our website. We have technical information regarding the significance of 4.0. We have architectural papers and solution briefs throughout the industry. We realize that the kind of performance and correctness that is now capable is a challenge to understand and really think through the architectural impacts of. Hopefully between this webinar as well as some of the information on our website, you can start to see how this may play a role in your organization's transformation.
Okay, great. So Brian, I think we'll take some questions now, if that's all right with you.
Sounds great.
Yeah, and folks, feel free to keep entering questions in the system, so it's great. What I'm seeing, Brian, are just some kind of requests for some clarification, so we'll kind of get right to it. One of them you talked about on the latency aspect, and if you don't mind, can you talk to the fact, it was something to the effect of, can you talk to the fact that if your 99th percentile latency will actually be your overall latency? Can you talk to the validity of that statement and what that actually means?
Sure. So the issue I've seen presented at a couple of conferences is that a typical service these days, a typical user experience, needs to reach out to a wide variety of data sources internally in order to present either a function call, the result of a microservice, or even render a web page. I remember going to a talk at a scalability conference that said an individual web render can be seen and measured on the internet by how many sub-functions are being used with outside components. And the average number for major websites is around 100. If you need to go and make 100 sub-requests to be able to pull together a rich experience, well, you need to go out and get each and every one of them. And maybe you can fill in some later, but for some calculations, a wide variety of calculations, you need to get all of the data back. So you need to go out and get those 100 requests and start the calculation when they're all in. If your calculation is of this sort, which many of them are, you're waiting for every result. If most of your results come back in, say, 0.1 millisecond, and then 10% come back within a millisecond, and then 1% take 20 milliseconds, well, you just waited for that 20 millisecond outlier, and thus the overall calculation time, regardless of the fact that many came back fast, is limited by the fact that that one outlier took 20 milliseconds. So now your average transaction speed latency is that 99% worst case latency. So that's the kind of architectural and technical problem that leads me to say that those worst case latencies really are paramount when considering a digital transformation.
Yeah, I think that makes perfect sense. Okay, with that, we'll get to the next question, which has to do with data and performance. So can you give an example or two, or maybe just describe in more detail where literally more data leads to quote unquote better outcomes? So why does a higher performing database matter to an enterprise's business?
Sure. So one of the cases that just became crystal clear to us is the fraud detection case. And so some of the older rules engines based systems were really only had a few different components to them. They would take a look, for example, at the location of a particular store. They would take a look at the last few transactions of a particular customer, but they couldn't look at, for example, the market basket inside past transactions. They would often have, say, are you buying 3 Rolex watches? That was a well-known fraud pattern 10 years ago. If you're buying identical watches, you're probably going to resell them. This is likely to be fraud, even though you might say, I'm buying this as a wedding gift for my 3 groomsmen. It might in fact be fraudulent. However, if you were able to look back in multiple transactions and actually see not just that a transaction occurred at, say, a gas station, but the number of gallons that you bought, whether it was high test or low test, all of these elements, if you can imagine that level of data richness really within the few milliseconds you have, you are certainly going to come up with a better result. Recommendations are another great case where a bit of data richness helps. And the underlying, it will be up to your data scientists. I was talking to a large-scale retailer in the East Coast area, and they had done some analysis on their current RAM-based 1 terabyte recommendation store, and simply found that even though it was doing okay, they had done the analysis to show that if they had not just the last 2 weeks of data, but had the long tail of a year, they could pick out a huge number more patterns. So am I coming back in this right now and doing a search, let's say a few days ago, even though that's the most actionable data and may fit a pattern, being able to look back with that user in the previous few months simply leads to richer recommendations. So I admit that's a little bit of a hand wave because it's certainly industry specific, but it is the element of a transformation. And we all do know that companies like Google and Amazon and Facebook are out there with huge data stores on the front edge. And those are the guys you have to beat.
Sure. Yeah. I mean, yeah. If you're able to look at more data over a greater horizon of time, you'll get greater insights. I think that makes sense. Are there certain? The next question has to do with machine language frameworks. Are there certain ML frameworks popular that you're seeing with Aerospike customers?
Yeah, that's a great question, Matt. So the interesting problem with ML and AI in general is trying to do it at scale. So where Aerospike excels is providing a broad set of data for your ML activities, where you may need different features for different users. You may be even implementing a multi-layer design where a high-level model may be choosing features and feature weights in real time. We certainly see some of that. And then you're then going to a particular set of features, and you need all of those features online because different models need them at different times. That's sort of traditional, but then the problem becomes what frameworks are actually capable of operating at this scale. And what we have found in our customer base, because a broad variety of our systems use ML, is that there is still an aspect of rolling your own at scale. Some of our customers have been using H2O.ai and using them extraordinarily successfully at modest scale and through, I would say, the mid-range of scale. We certainly see a variety of people using Spark ML. But then what I start seeing at the higher levels of scale is people plucking these open source libraries out and writing their own code around them. So the ability to do the math is already part of these libraries, and they're ending up putting them in their own infrastructure. I think this is an area where there's an opportunity for some innovation and some high-scale ML systems to come of age.
And are a lot of these ML systems, are they using, at least in industry, are they using cache-based systems?
Yes. So what we find in these large-scale ML systems is a wide variety of databases. We find that practitioners of ML using multi-layer models, using sometimes fast model recalculation, will put in a variety of caches throughout their system. And that's good news. The good news is that with the kind of ML systems that you have, you can build out a variety of technologies. What we find at Aerospike is that being able to have a single broader system with more capabilities is more flexible. And one of the jokes about AI is that it might be smart, but it can't explain itself. So the ability to have a system that can reach for different features in different systems according to its own internal discoveries becomes a real benefit in ML.
Great. And so is it that cache-based systems, are they largely inconsistent, or are they, is it typical for a cache-based system to not be strongly consistent, I guess?
Well, whenever you have a cache, you have two elements of truth. You're not reading from the source of truth. You almost always, you do not have a strongly consistent system when you have two components, one that's a cache and one that's your database.
Got it. So, okay, I think maybe we'll have time for one or just two other questions. And so it seems that Oracle is, the main Oracle database is viewed as, a transactional database it's inherently strongly consistent. Is Aerospike replacing Oracle types of systems?
Yeah, great question, Matt. The reality of today is if you are undergoing a digital transformation in your enterprise, you've got enough problems bringing online new technology. Trying to supplant old technology is a bridge too far. And so even though there are a variety of new and exciting technologies that could replace Oracle, I do not recommend anyone walks into their transformation and say, hey, we're going to rip out Oracle. You've got a target on your back there. So the real aspect is to come in with a high impact proposal as part of your transformation that adds to the capabilities of your system, that provides, say, a microservice that turns out to be high value, that is alongside many of your traditional enterprise systems and Oracle systems. So while I have seen Aerospike replace Oracle brand components, such as the ×10 in-memory database and the coherence caching subsystem, and starting to take over some of the activities of the traditional Oracle system, I think it's one should not walk in saying you're going to replace Oracle.
Fair enough. Okay. Well, I think with that, we will close the webinar. Thank you, those of us, for staying with. And we will, again, have copies of the slides and the presentation on demand for you. So thanks again, Brian, for the webinar. And thanks, everyone. Have a great day.
Thank you, Matt.